Alright, in this video we're going to be solving the hardest pure 1 questions that Cambridge asked in 2025. Number 5. An arithmetic progression has the first term 5 and common difference 6. With this progression, find the sum of all the terms that lie between 150 and 400. 6 marks. What a question. Okay. So let's just digress for a little bit so we can actually understand what on earth is going on here. So if I gave you an arithmetic progression of the form, let's say it starts with the term 2, and then it goes on to 4, it goes on to 6, clearly our common difference, yes, is 2, 8, and 10, and 12, and 14, and it continues to go on. And then I asked you to find the sum of all the terms that lie between 5 and 11, right? Like sum of all terms between 5 and 11. So between 5 and 11, the first term that's more than 5 is your 6. The last term that fits within this interval 5 and 11 would be 10. So what I'd be asking you to do is to find the sum of 6 plus 8 plus 10, which would be 24 in this case. So this is exactly what the question is asking you to do, except now it's with 150 and 400. Obviously, we can't just try to write out the whole progression until we find the first term that's more than 150 and the last term that's less than 400. That would be way too long. So we want to do the same thing, but of course at a bigger scale. So we need to find here, like we did, we need to find the first term that fits within this interval, and we also need to find the last term that fits within this interval. So the way we can do that is to say, I'll call this first term that fits within our interval, I'll say that it's term number P, or the term in position P, and the last term, I'll put it in position Q. So we want the first term that fits within this interval, it has to be at least 150, right? Because maybe let me scale this up so that it actually makes sense. We could have something of the form, so obviously our first term is 5 and 11, and then this would continue to go on until we get to maybe, we could do 1, let's say it's 148, and then the next term, if we add 6, is 154, 160, 166, and then this would continue to go on, let's say to maybe 398, or let's do 392 and then 398, 398, and then after this it's plus 6, 404. So assuming that this is what our sequence looks like, right? It would mean our cutoff point would be here, because this is the first term that's more than 150, and then our cutoff point this side is here, because this is the last term that's more than 150 but less than 400. So we need to find the actual positions of these terms. This is what I've called P, and this is what I've called Q. We need to find what position P actually is, because once we have that, then I'll know the first term that fits within this range they've given us. If I find Q, I'll know the last term that's in this range. And once we have that information, it's very easy to get the sum. So we're saying that the term in this position, it can be equal to 150, right? But as you've seen in my example, it may not be necessarily be equal to 150 because the term previous to that is 148, which is not 150, right? So the first term that's greater or equal to 150 is 154. So that's a possibility. So that's why we're not just saying UP is equal to 150 because it may not necessarily be equal to 150. Okay, and then we'd do the same thing for the last term, which we're calling UQ. This one has to be less than or equal to 400, right? Because here, as we can tell, that's 398. The last term that we will accept is 400. Anything more than 400, we won't accept. So we want to find the last term that's just less than 400 or equal to, if that's the case. So the UP, we're using our nth term formula, which says a plus n minus 1d. UP is going to be a is 5 plus our n, that's p, minus 1, our d, that's 6, and this is greater or equal to 150. Okay, and so this is going to be, we want to make p subject of this inequality. So I'm going to move the 5 to the other side. I've got p minus 1 times 6 is greater or equal to 150 minus 5, that's 145. Divide both sides by 6. P minus 1 is greater or equal to 145 over 6. Add 1 to both sides, so P is greater than or equal to, excuse me, P is greater than or equal to, the maths is killing me, 145 over 6 plus 1, which is 25.1667. Right. I want you to keep in mind that P represents the position, right? The 5 is the term in position 1. The 11 is the term in position 2. The P, or the 154 in this case, is the term in position P. So P is going to be an integer. So we want the integer value of the first term that's greater than 150. So the first term that's greater than 150 is going to be in position 26 because that's the first integer that's greater than or equal to. That's the first integer that's greater than 25. So P has to be 26. And we can double check this. If we are to do U26, that's going to be A plus n minus 1, 26 minus 1, D. So that's 5 plus 25 times 6. That gives us 155. And so now what you actually notice, we're actually pretty close with our guess. What you notice is that the first term here is going to be 155. That's the first term that's over 150. And the previous term, we can get that because we know what D is. Our D is 6, so it must mean the previous term is 149. And clearly 149 is not 149 is not greater than 150, so it's not within the interval that we want. 155, that's position 26. This is position 25. And then if I added there, that would be 161, 167. And we continue. Now we need to figure out what the cutoff point is on this side. The last number that's less than 400. So we get that from saying that we want a term that's less than or equal to 400. So that's going to be same procedure, nth term formula, 5 plus q minus 1 times d, which is 6, less than or equal to 400. Subtract 5 from both sides, q minus 1 times 6 is less than or equal to 395. Divide both sides by 6, q minus 1 is less than or equal to 395 divided by 6. Add 1 to both sides, 395 over 6 plus 1. Q is less than or equal to, so that's 395 over 6 plus 1, which is 66.833. So we want the last term that's less than or equal to 400. So we want the last integer value that's less than or equal to 66.83. So the last integer value, because remember q is a position, so it's an integer, because the number of the term is going to be a whole number. It's going to be an integer. Here, this is just guiding us and telling us that q has to be less than 66.833. But the last integer value that satisfies this condition is 66. So it would mean that, and we can double check again like we did, it would mean that u66 is the last term that's less than or equal to 400. So we can check u66 is a plus n minus 1 d, which is equal to 5 plus 65 times 6. That's 395. Okay, so what this would mean is that the last term here is 395. The one before that would have been 395 minus 6, 389. And then the first one outside of the boundary is 395 plus 6, which is 401. So that would be 395. We say that's term 66. This would be term 67. So I hope this makes sense, that the last term that's less than or equal to 400 is the term 395, which is in position 66. And now all we want to do is to find the sum of the numbers within this interval. And to do that, we can say the sum of the first 66 terms. So that will give us everything here. But we need to subtract the sum of the first 25 terms. Because if I remove the first 25 terms, I just remain with term 26 all the way up to term 66. Okay. And so to do that, we can use our nth term formula, which is half n times 2a plus n minus 1d. So for S66, that's going to be 66 over 2 times 2a being 5 plus n minus 1, so 66 minus 1 times d, minus 25 over 2 times 2 times a being 5 plus n minus 1, 25 minus 1 multiplied by 6. Let's simplify this part first. So that's 66 over 2 times 2 times 5 plus 65 times 6, 13,200, minus, that's 25 over 2 times 2 times 5 plus 25 minus 1 times 6. That's 1925. We subtract that from 13,200. We get 11,275. I hope that makes sense. Number 9. A curve is such that d squared y dx squared is 6 over x to the 4 minus 5 over x to the 3. It is given that it's got a stationary point at half 9. That's a stationary point. In my head, I'm already processing. I've seen a stationary point. dy dx has to be 0, right? And then in part A, they say that use the expression for d squared y dx squared to determine whether the stationary point is a maximum or a minimum point. Okay. So here we're just evaluating our second derivative at the stationary point. So we're evaluating the second derivative at x is equal to 1 over 2. This is just fancy notation to say that I'm evaluating my second derivative when x is 1 over 2. Okay, so substitute x with 1 over 2, 6 over 1 over 2 to the 4 minus 5 over 1 over 2 to the 3. This is equal to, that's 6 over 1 over 2 to the 4 minus 5 over 1 over 2 to the 3. That's 56. So since our second derivative is equal to 56, which is greater than 0, the point, what's the point again? Half 9 is A. That's going to be a minimum point. If your second derivative is positive, you've got a minimum point. If it's negative, you've got a maximum point. And part B says find the equation of the curve. 7 marks. That's a hell of a question. Okay. So we're starting with the second derivative. Just write d squared dx squared. We're starting with the second derivative, d squared y dx squared. If you integrate this, you get the first derivative dy dx. And if you integrate this, you get the equation of the curve. Y is equal to whatever it's equal to, right? So we are going to have to integrate twice. If you integrate second derivative, you get first derivative. If you integrate first derivative, you get the equation of your curve. So that's why that's worth 7 marks, because you're going to have to integrate twice. What is our second derivative? We've got d squared y dx squared, and this is equal to 6. I'll bring the x to the 4 up to the numerator. It becomes x to the negative 4 minus 5. I'll bring the x to the 3 up to the numerator. It becomes x to the negative 3. And so we want to integrate this. We're going to integrate both sides with respect to x. If you integrate the second derivative with respect to x, you get dy dx. If you integrate 6x to the minus 4, you're going to add 1 to the power. So negative 4 plus 1, that's negative 3. Divide by the new power, minus 5x. Add 1 to negative 3, so negative 3 plus 1, that's negative 2. Divide. And remember, always add a constant of integration. So dy dx is equal to 6 over negative 3, that's negative 2, x to the negative 3, negative 5 over negative 2, that's positive 5 over 2, x to the negative 2, plus our constant of integration. We're going to need to integrate for a second time. But before we integrate, we actually need to find what our constant here is, right? And so that's where that whole stationary point comes into effect. So we know that when x is 1 over 2 and y is 9, dy dx is 0. We can use that bit of information to help us find our constant. So we know that our dy dx is 0 when x is equal to 1 over 2. So 1 over 2 to the negative 3 plus 5 over 2. 1 over 2 to the negative 2. Again, because it's a stationary point, dy dx has to be 0. So you've got 0 is equal to, that's negative 2 multiplied by 1 over 2 to the power of negative 3 plus 5 over 2 times 1 over 2 to the power of negative 2. So negative 6 plus c, so c has to be 6. And so we have that our dy dx is equal to, that's negative 2x to the negative 3 plus 5 over 2 x to the negative 2 plus 6. All right. And now that we've evaluated the constant, we can now integrate both sides so that we can get our equation of the curve. So again, you're integrating both sides with respect to x. So I'd made a mistake on integrating this. So I noticed that after I'd finished recording. So I'm just going to correct that. So if you integrate dy dx with respect to x, you get y. And then if you integrate negative 2x to the negative 3, that's negative 2x, add 1 to negative 3, that's negative 2, divide by negative 2. And then you've got plus, you've got 5 divided by 2, x, add 1 here, negative 2 plus 1, that's negative 1, divide by that negative 1, plus 6, that becomes x, and of course plus a constant, excuse me, of integration. So we've got y is equal to negative 2 over negative 2, that's 1, so that's just x to the negative 2. And then here we've got 5 over 2 times negative 1, so that's negative 5 over 2, and that's x to the negative 1 plus our 6x plus our constant of integration. And remember, we have been told about the stationary point with coordinates half 9. So we know that when y is equal to 9, and we can use that information to evaluate our constant of integration. So 9 is equal to 1 over 2 x, or 1 over 2 to the negative 2 minus 5 over 2, 1 over 2 to the negative 1 plus 6 times 1 over 2 plus k. And we've got 9 on this side, and then we've got, that's 1 over 2 to the negative 2 minus 5 over 2 times half to the negative 1 plus 6 times half, which gives us 2 plus k. So our constant here should be 9 minus 2, which is 7. And so therefore, the equation of the curve becomes y is x to the negative 2 minus 5 over 2, x to the negative 1 plus 6x plus 7. And that's the 7 marker. The idea behind it is not too difficult. If you understand the purpose of integration, if you start with the second derivative, you integrate, you get to the first derivative. You integrate the first derivative, you get to the equation of the curve. But it's more so just when you integrate the second derivative, you're going to get a constant, right? When you're at your first derivative stage. Here, it's what to do with that constant. That's the tricky part. But remember that at a stationary point, dy dx is 0. So we know that we had our stationary point which had coordinates half 9. So we know that when x is half, dy dx is 0. And then use that, get your c, integrate again, and then use the same point, but now using x and y coordinates to get your other constant of integration. And then, yeah, you get your equation of the curve. Not too difficult, just be careful to not make any silly mistakes. Number 6. So the question reads, the diagram shows the curve with equation y is equal to 9 over 5x plus 4 to the half, and the line with the equation y is equal to 6 minus 3x. The line and the curve intersect at the point P, which has y coordinate 3. We don't know what x is, but we know y is 3. Find the area of the shaded region. Okay, so let's just find the x coordinate at P first. So we can do that by just substituting into the equation of the line, because we know point P lies on the line. So I know that y is 3. So that's 3 is equal to 6 minus 3x. So 3x has to be 6 minus 3. So 3x is 3. X is 1. So that means that point there is x coordinate 1. All right, that's a start. And I think the next thing we would like to know, because obviously the big picture here is to just integrate and get the area under these functions, right? That's the big picture. But to be able to do that, I first need to know the x coordinate, which we just found there. And then I also need to know what the x coordinate here is. Because what we're going to do is we're going to say the area under the curve from 0 to the point P, because that's just the area under this curve here, right? That's not too much of a problem. But we can't continue to just say area under the curve beyond this point, because can you see that the shaded area is no longer bounded by the curve, but it's actually now bounded by the line. So once we go beyond P, it's now area under the line and not area under the curve. So that's why we need to know the point P, and then we also need to know what the coordinates are here, because that's the final bound of our shaded region. To get that, this is just the point at which our line intersects the x-axis. So the x-axis has y being 0. So at y is 0, what is x? So you get 3x is 6, divide both sides by 3, x is 2. And so that means this had x is 1, this has x is 2. Okay. And so like we've just explained here, to get our area, it's going to be area under the curve from 0 to 1. Area under curve and we're saying from 0 to 1 plus, once we pass 1, our shaded region is now bound by the line. So plus the area under the line from 1 to 2. And so to get those areas, we can just integrate. So we integrate the curve, which has a ridiculous equation. Notice that we can bring this up top, so that this is 9 times 5x plus 4 to the negative half, because that allows us to integrate. We can't integrate it from down there. So we're integrating that, and our limits are 0 to 1. And then from 1 to 2, we're now integrating the line 6 minus 3x with respect to x. Okay. So let's start by integrating our curve. So start with the outer function, so the one with the power negative a half. So you just write the whole thing, 9, 5x plus 4, and now add 1 to negative 1 over 2. That becomes positive 1 over 2. Divide by the new power. And now differentiate the inner function. So if you differentiate 5x plus 4, you get a 5. And that's that. We're integrating from 0 to 1 plus, now let's integrate this. So integrate the 6, you get 6x, negative 3x, add 1 to 1, you get 2, divide by the new power, and this is from 1 to 2. And let's maybe simplify the first bracket. We've got 9 over 0.5 times 5, which is 18 over 5. And in fact, I can take the 18 over 5 outside the bracket so that it doesn't complicate things. And so I've just got 5x plus 4 to the half. And this is from 0 to 1 plus the 6x minus 3 over 2x squared from 1 to 2. And now we can substitute in our limits. So here I've got 18 over 5. Substitute the upper limit. That's 5x. X is 1 plus 4, and this is to the half, minus the lower limit. That's 5 times 0 plus 4 to the half. And we'll do the second one. So start with the upper limit, 6 times 2 minus 3 over 2 times 2 squared. And then we'll do the lower limit, so that's 6 times 1 minus 3 over 2 times 1, that's squared. All right, so let's simplify. This is 18 over 5. Let's punch this into the calculator. That's 5 times 1 plus 4 to the half, which is just 3, minus root 4, so 3 minus 2, so that's just 1 then, plus, let's punch this whole bracket into the calculator. So that is 6 times 2 minus 3 over 2 times 2 squared, minus 6 times 1 minus 3 over 2 times 1. And so from there we get 3 over 2. So 18 over 5 plus 3 over 2. And that gives us 51 over 10. And so therefore our area is 5.1. Question number 6. An arithmetic progression has first term a and common difference 2. Okay, so we've got an AP where the first term is a and our common difference is 2. We're told that the nth term is 55 and the sum of the first 3 n terms is 5760. Find the values of big N and small a. Okay, so this should also be big N because they use big N. Alright, so from the MF19, you'll find that the nth term of an AP is a plus n minus 1d, and you'll also find that the sum of the first n terms is n over 2 times 2a plus n minus 1d. Okay. Our goal here is to find n and a. We've got these two pieces of information. We can use those to create two simultaneous equations in terms of, it's going to be in terms of n and a, and then solve those simultaneously. Right. So un, we can substitute into the nth term formula there. That would be a plus n minus 1. So our n is the big N minus 1. D is 2. And we know that this is equal to 55. Right? And then sum of first 3n terms. So that's going to be 3n, because our n is 3n, over 2 multiplied by 2a plus n, which is 3n, minus 1 times d, which is 2. And we know that this is equal to 5760. Let's make a subject of the formula in this first equation. So we get a is equal to 55, and then move this block to the right. So 55 minus the 2 times n minus 1. In fact, let's expand that. So a is 55 minus 2 times n minus 2 times minus 1, which becomes plus 2. So a is equal to 57 minus 2n. All right, and so we can substitute that in here. So we've got 3n over 2 multiplied by 2 times a is 57 minus 2n plus the 3n minus 1 multiplied by 2, and this is all equal to 5760. So I think for starters, we can just multiply both sides by 2 to get rid of that fraction. And so I've got 3n outside here, and it's multiplying 2 times 57. That's 104, right? 114. My word. Shocking. 2 times negative 2n, negative 4n, plus 3n times 2, 6n, minus 1 times 2, minus 2. And this is equal to 5760 times 2, 11,520. Should probably have divided by 3 as well. What do we get if we divide by 3? Okay, so I'm just going to divide both sides by 3 so I can eliminate that 3 there. So I don't want that there. So on the left, I've got n. And then let's simplify like terms inside the brackets. So 114 minus 2 is 112. Then 6n minus 4n, that's plus 2n. And on the right hand side, we get 3840. And then multiply through. So n times 112, that's 112n. N times 2n, that's 2n squared, is equal to 3840. Let's put everything on one side. So I'll move this to the left. So 2n squared plus 1112n minus 3840 is equal to 0. Let's divide through by 2 so that we've got big N squared plus 112 divided by 2, which is 56n, and then 3840 divided by 2, which is 1920, is equal to 0. So let's use the quadratic formula. So n is equal to minus b, b being 56, plus minus the square root of b squared. So 56 squared minus 4a. A is the coefficient on n squared, so that's 1 times the constant c, which is negative 1920. And this is all over 2 times a being 1. And so n is equal to, let's punch this into the calculator, negative 56, negative root 56 squared, negative 4 times 1 times negative 1920 over 2 times 1, which is negative 80, or n is 24. Those are the two possible solutions. And in the context of this term, remember that n is representing the nth term. It wouldn't make sense for us to say the negative 80th term, right? We can't have a negative, like a term in a negative position. Remember, our terms start from term number 1, going to term number 2, going to term number 3, and so on. The positions for our terms are always positive. They can't be negative. So I can't have negative 80th term. So I know that n has to be 24. N has to be 24, and then a, if n is 24, a has to be 57 minus 2 times 24. So a is 57 minus 48, which is 9. So we can conclude that, therefore, a is 9, big N is 24, and that is our final answer. Number 8. Oh my. It's an 8-mark question. And it has no diagram. Damn. The circle with the equation x squared plus y squared minus 6x plus 10y minus 27 equals 0 intersects the line x equals negative 2, intersects x equals negative 2 at points P and Q. Find the area of the triangle formed by the tangents to the circle at P and Q, and the line x is negative 2. Oof. This is some question. Let's see if we can draw out a diagram. That was supposed to be a circle. Okay, there we go. So we've got a circle with a center that we're going to have to find. And then we're told that the circle intersects the line x is -2. So if this is x is -2, then these would be points P and Q. And then we are told that the tangents to the circle at P and Q. So we need to draw tangents to the circle at P and Q. That's 1. Why does that not want to straighten up? It's 2. Let's just shift that up. And then the question is to find the area of this triangle here. Okay. So for starters, we should probably find the coordinates of the center of the circle, right? Because we've been given the expanded form of the circle. So what you're going to do is put everything that is x next to each other. So x squared minus 6x plus everything that is y together, y squared plus 10y. In fact, I'm probably going to put brackets here. And then the constant, take it to the other side. So equals 27. And then you're going to complete the square for x by itself and complete the square for y by itself. So if we complete the square there, that's x minus 6/2, which is 3, squared. 3 squared is 9, so minus 9. And then if you do the same, here you've got y plus 10/2, which is 5, squared. 5 squared is 25, so minus 25. This is equal to 27. Move all constants to the right hand side. So you've got x minus 3 squared plus y plus 5 squared is equal to 9 plus 25 plus 27, which is 34 plus 27, so 61. So we have that x minus 3 squared plus y plus 5 squared is equal to 61. Remember that the equation of a circle is of the form x minus a squared plus y minus b squared is equal to r squared. So that means, rather, where a, b are the coordinates of the center, and then r is your radius. So in our case, it means our center has coordinates 3, and this is y minus 5. So 3 and -5. That's our center there. All right, our radius would be r squared is equal to 61, so radius will be root 61, but it is not relevant at the moment. The next thing that I think, okay, so the big picture here is obviously we want area of the triangle, and the way we can do that is to find the length of our base here, and then find the height of our triangle, and then just use half base times height. So that's the big picture of how we want to approach this question. To do that, what we're going to do is first, we can find what the y coordinate of P is and what the y coordinate of Q is. Once we have that information, we can just subtract the two to get our base. And then the height is the one that's a bit tricky. We're going to find the equation of each of these two green tangents. And then we're going to find the coordinates of the points of intersection. Once we know that, we can get this distance here. And once we have that, we have our height, and then we can just do half base times height. So that's the big picture. We know that at P and Q, x is -2, and P and Q lie on the circle, so they satisfy this equation here. So I can substitute x with minus 2 to find what y is. Right? So I can say -2 -3 squared plus y plus 5 squared is equal to 61. And so that's -5 squared, which is 25, plus y plus 5 squared is equal to 61. Let's make y subject of the formula. So y plus 5 squared is equal to 61 minus 25, which is 36. Take the square root on both sides. Y plus 5 is plus or minus square root of 36, which is 6. So y is equal to -5 plus or minus 6. So we have that here, that either y is 6 minus 5, which is 1, or y is equal to -5 minus 6, which is -11. Okay, so that must mean q is the one that is -11, because that's the one that's at the bottom. So q has coordinates -2, -11, and then p would have -2, and y is 1. P is -2 and y is 1. And so we can tell that our base here, the base of the triangle PQ, is going to be equal to, that's just 1 minus -11, which is equal to 12 units. And now we need to work on finding our height. So we need to find the equation of our green tangents. These are tangents to the circle. So we need the gradient as well as a point. We already have the point. If we're looking at the tangent at P, we already have the point -2, 1. But we need to know what the gradient is of our tangent. To do that, we can use the idea that the tangent is going to be perpendicular to our radius. So if I can find the gradient of the radius, then I can deduce the gradient of our tangent. So gradient of our radius to P, gradient of radius to P is equal to, that's going to be change in y, so -5, -1 over change in x, which is 3 minus -2. So that's -6 over 5. This is the gradient of the radius to P. So because the radius is perpendicular to our tangent, it must mean that the gradient of the tangent at P is equal to, just flip this and change the sign. So 5 over 6. That's the gradient of our tangent. And now that I have the gradient, I just need to know what the y-intercept is. So we want to use y equals mx plus c. We know that m is 5 over 6, and we have the point -2, 1. So y is 1, m is 5 over 6, x is -2, plus c. C becomes 1 plus 2 times 5, 10 over 6. So c is 8/3. So we have that the tangent at P has the equation y equals 5 over 6x plus 8/3. So that tangent there has equation y is equal to 5 over 6x plus 8/3. Now we need to do the same for the other tangent. So first get the gradient of the radius to Q. So we want gradient of radius to Q. This is equal to change in y. So -5, -11 over 3 minus -2. So 3 plus 2, which is equal to, this is 11 minus 5. So this would be, okay, 6 over 5. It's the same gradient as MRP, except that MRP is just negative. It's like the negative version. Okay, that's fine. So it means that the gradient of the tangent at Q is equal to, flip this and change the sign. So that becomes negative 5 over 6. And so again, same procedure. Here we have the point negative 2, negative 11. So we've got negative 11 is equal to m, which is our negative 5 over 6, multiplied by x, which is the negative 2, plus c. So we have that c is equal to, that's negative 11 minus 5 times minus 2, so positive 10, so minus 10 over 6 when we move it to the other side. So c is minus 11 minus 10 over 6, which is minus 38 over 3. All right. And so y here has to be negative 5 over 6x minus 38 over 3. So the equation of our tangent here is y is minus 5 over 6x minus 38 over 3. And so now what we need to do is to find where these two tangents intersect. We want those coordinates. And to do that, we solve simultaneously. So just equate these two together. So that's, let's do it in blue, or rather in green. That's 5 over 6x plus 8 over 3 is equal to negative 5 over 6x minus 38 over 3. And let's put everything that is x on one side and everything else on the other side. And so we have 10 over 6x is equal to, that's negative 38, negative 8. So negative 46 over 3. Multiply both sides by 6 over 10. And we have negative 46 over 3 by 6 over 10, which gives us negative 46 over 5. And I think we only need, yes, we only need the x coordinate here. So this means that at this point here, x is equal to negative 46 over 5. So now we can get the height of our triangle. Because remember, the height of our triangle is this here, which is the distance between negative 2 and negative 46 over 5. So that there is going to be, that's minus 2 minus 46 over 5, which gives us minus 2 plus 46 over 5, which is 36 over 5. So it means that distance there is 36 over 5. And so this is the height of our triangle and our base is 12. So we can get the area of our triangle and say that area of our triangle is half base, base being 12 times height, height being 36 over 5. And therefore the area of our triangle is equal to, that's half times 12 times 36 over 5, which is 216 over 5. And that there is our final answer. This question is a lot of work. I mean, the least they could have done is give a diagram. But Cambridge were out for blood, apparently. On to question number 10, which I am very adamant that this looks like the cross section of an eyeball. Okay, so we're given that the diagram shows a circle with center A and radius R passing through the points B, C, and D. A larger circle of radius S has center C and passes through B and D. The length BD is also S. Part A, show that S is root 3R. So if we analyze our diagram here, I hope you can see that this triangle here BCD is an equilateral triangle because each side has length S, and because it's an equilateral triangle, this must mean that this here is pi over 3. And because this here is pi over 3, we know that the angle at the center of a circle is twice the angle at the circumference of the circle. That's a circle theorem. So this angle that's at the center of the circle, right? A is the center of this small circle that's inside. So the angle at the center has to be twice that angle. So this has to be 2 pi over 3. And this is relevant because now what we can do is to look at the triangle ABD, which is this triangle here, and we want to use the sine rule with that triangle. I'm just going to do that triangle on the side so we have more space. So that's an isosceles triangle, and we know that this angle here is 2 pi over 3. And since this is isosceles, our base angles are going to have to be equal, and I can get my base angles by saying all the angles should add up to pi. So pi minus 2 pi over 3 divided by 2. That's going to give us, that's pi over 3 divided by 2, so pi over 6. So these angles here are pi over 6. That's pi over 6. We know that since this is A, B, D, we know that AB is R as given in the diagram, and AD is also R, and then BD is S. So we can use the sine rule here and say that I know the length S corresponds to the angle 2/3 pi. So I can say that S divided by sine of 2/3 pi has to be equal to, then I know that this angle pi over 6 corresponds to the length R. So I can say that R divided by sine pi over 6. And here our goal is to get an expression for S in terms of R. So we need to make S the subject of the formula. So this is S is equal to your R divided by sine pi over 6 multiplied by the sine 2/3 pi. So S is equal to, let's simplify those signs. So I've got sine of, make sure you're in radians, 2/3 pi divided by sine of pi over 6. And that gives us a root 3. And don't forget that this is being multiplied by R. So that is indeed S is equal to root 3R. And that's going to be our final answer. Now in part B, we are required to find an expression for the area of the shaded region. Give your answer in the form a plus b pi r squared, where a and b are constants to be found, for 7 marks. So let's just copy our diagram here. And so what we want to do is to come up with an expression for the area of the shaded region. So what we can say is, I hope you can see that if we do the circle with the center A, so that's this circle here, that circle there, that's going to be our starting point. And then we're going to subtract shapes from there to get what we want, which is the shaded region. So the area we want is going to start with circle A, the circle with center A, and from here we want to subtract the sector B, C, D, which I'll put in blue. This sector is coming from center C, the big circle with center C, right? And we want to subtract that sector because if I just shade it in, right, this pizza slice from the big circle, if we subtract that, then all we will need to also subtract is these two segments here. So I'm gonna just write the expression out as it's going to be the circle A minus our sector BCD minus our two segments. So I'll use the segment BC, which is this one here, right? So minus two segments BC. So let's start by finding the area of circle A. So circle A, area of a circle is pi r squared. So that's pi times the radius of the small circle is r. We can see it from this diagram here, which is clearer. Our radius there is r. So it's just literally pi r squared. And then we want the sector BCD. right? Our blue pizza slice. The area of a sector from the MF19 is half r squared theta. So area of a sector is half r squared theta. So in our case, this is half times the radius. So BCD is coming from the big circle with center C. So its radius is S. It's the distance from C to D. That's the radius. So it's half times S squared times theta. What's the angle inside that sector, inside that pizza slice? That's your pi over 3, which we deduced in part A. So that's half s squared times pi over 3. And then we know that s from part A, we know that s is just root 3r. So this is just half times root 3r squared times pi over 3. So I've got half times root 3 squared becomes 3, and then r squared times your pi over 3. Okay, so the 3's cancel out, and we end up with 1 over 2 times pi times r squared. That's your sector BCD. Now we need to find the area of our segment BC. Okay, so I think I'll use the diagram above to illustrate this because it can get a little bit messy. In fact, let's erase all of this. Okay, we do know that this angle here is pi over 3, and then angle at the center is twice angle at the circumference, so that's 2/3 pi. Okay, and I hope you can see that all these angles are going to be the same. They're all going to be 2/3 pi, simply because I've got an equilateral triangle, right? And we've split it into 3 equal triangles, so all those angles will match. So this is also 2/3 pi. What we're interested in is finding this region here, the segment. So to get that segment, I'm going to do the sector A, B, C, right? And then I have to subtract the triangle that's inside, and that will leave me with a green region. So segment BC is going to be my sector ABC, sector ABC minus triangle ABC. Okay, so as we discussed earlier, sector area is half r squared theta. So half times, here our radius is this r because we're dealing with a small circle, not the big circle. So half times r squared times theta. Our theta is the angle inside your pizza slice. In this case, that's the 2/3 pi. So 2/3 pi. And then area of a triangle, we are actually going to use half AB sine theta. So this is where you have a situation like this, where you've got theta and you've got A and B, right? So in our case, this is minus half. Our A is going to be this radius, our B is this radius, and our theta is the 2/3 pi. So that's half r squared times sine of theta, which is 2/3. Okay. And then let's simplify this. Let's just move this to the side. So this is half times 2/3. That's going to, the 2's cancel out, so you end up with 1/3 pi r squared minus, we've got here a half r squared. What's sine 2/3 pi? Sine 2/3 pi, that is root 3 over 2. So I've got a half r squared times root 3 over 2. So this is 1/3 pi r squared, and I've got minus 1 over 2 times root 3 over 2. That is negative root 3 over 4 r squared. This is the area of a segment BC. Right, so let's take this down. Okay, so now we have all the information that we need to get our area. So we said our area is going to be the circle A, which has the area pi r squared, minus the sector BCD, which is a half pi r squared, minus 2 times segment BC. We know that segment BC is 1 over 3 pi r squared minus root 3 over 4. r squared. And now we need to simplify. So I've got a is here here I've got pi r squared minus a half pi r squared. So I hope you can see that the pi r squared is common, right? So essentially it's like, well, we are factoring out pi r squared, so you end up with 1 minus half. And then here I'll expand that bracket, so that's minus 2/3 pi r squared, and then minus 2 times minus root 3 over 4 r squared. So that becomes positive root 3 over 2 r squared. And so a is, so 1 minus a half, that's half, so half pi r squared. That's minus 2/3 pi r squared plus root 3 over 2 r squared. And here, let's just start off by factoring out the r squared in all the terms. So I'm going to have a half pi minus 2/3 pi plus root 3 over 2 and the r squared outside. Then we can simplify like terms. So I've got a half pi minus 2/3. So half minus 2/3 pi. That is negative 1 over 6 pi plus root 3 over 2 r squared. Let's just make sure that we have it in the form that they have requested. So they said a plus b pi r squared. So our b pi is this. So I'm just going to switch them around. But this is the final answer. So a is root 3 over 2 minus 1 over 6 pi. And that's being multiplied by r squared. And that's an expression for the area of the shaded region. What a question. Question number 9. The diagram shows part of the curve with equation y is equal to a half x plus 4 over x, and the line y is equal to 4.5. Find the exact volume of the solid formed when the shaded region is rotated through 360 degrees about the x-axis. Okay, so let me copy this diagram because I want us to visualize this so-called volume of revolution. Okay, so if I extend the y-axis and I just want to reflect the diagram that they have, so I'm going to reflect that line there, that horizontal line, which looks like that, and I'm going to try to reflect the shaded region as well, so something like that. Let me pull it down a little bit here, something like that. And this is the shaded region. So when we talk about volume of revolution around the x-axis, what you're going to do is you're going to take each point that bounds your shaded region and rotate it 360 degrees around your x-axis. So there's the other point, 360 degrees around the x-axis. And so I hope you can see that if we just focus on, initially, if we just focus on the red part, our volume looks to be forming a cylinder. So think about this as if you have a can of beans, right? So you've got your can of beans, that's the red part. I know it's a bad can of beans. And then inside, you've got something of this form. Don't know what you'd call this. The only thing I can think of is like a vase, right? So it's like you've got this vase and you've put it inside the can of beans. And so the area that we want, not the area, but the volume that we want is the volume that's going to be between your can of beans and this blue vase. Like by vase, I'm referring to like a vase you put flowers in, by the way. So this area that's going to be the gap that will be formed between your vase and your can of beans. That's the region that we want. And by the way, all of this is then rotated because we're looking at the x-axis. So you've got your vase inside the can of beans. So you want the gap that's going to be in between your vase, and your can of beans. That's what we want to find, because that would then give us this shaded region, when that shaded region is going to be rotated around. It's like the gap between your can of beans and your vase. Okay, so how do we actually find this volume? So if you're rotating around the x-axis, the formula you use is pi, the integral from a to b, and this is going to be y squared with respect to x. So in our case, what we're going to do is we're going to find the volume of the can of beans. So a and b are the limits in the x-axis that bound your region. So the can of beans is bounded by whatever this value here is, and whatever that value here is, which we are going to need to find. So let's just quickly do that, because that's going to be the point of intersection between our curve and our line y equals 4.5. So we can quickly equate those two. We've got 4.5 is equal to a half x, or it's going to be a quadratic. Okay, so it might take us a bit of time. So 4.5, I don't like having a decimal. 4.5 is the same as 9 over 2. And we're going to multiply through by 2x, because I want to get rid of all the denominators. So if I multiply 9 over 2 by 2x, I'm going to get 9x. If I multiply 1 over 2x by 2x, the 2's cancel out, and then I've got x times x, which is x squared. Then if I multiply 4 over x by 2x, the x's cancel out, then I've got 4 times 2, which is 8. So I've got x squared, take the 9x to the right, negative 9x, that's 8, and this is all equal to 0. Can we factorize this? I really hope we can, because if we can't, then what are we doing? Okay, factors of 8 that add up to negative 9. So that's going to be negative 8, negative 1. All right, and so either x is 1 or x is 8. There's our side quest done. So we know that at this point here, x is 1, and at this point here, x is 8. So that means that's 1, that's 8. That means our can of beans, or our cylinder, is bounded between 1 and 8 in the x-axis. And we know that the equation that's bounding our can of beans is literally just that red line on top. Okay, so that red line, we know it to be y is equal to 4.5. I'll write it as 9 over 2. And according to our volume equation, we want y squared. So y squared is going to be 9 over 2 squared. So square the 9, you get 81. Square the 2, you get 4. So here I'm going to have 81 over 4 with respect to x. This is what I'm going to integrate. And that will give me the volume of the cylinder, or the volume of our can of beans. And then now to deal with our vase, right, which is being generated by the curve, we're using the same formula, and remember this time we want to subtract it. Reason being, we want the gap between your beans and your vase. So this is pi, the integral from our vase is again bounded at 1 and 8. So 1 and 8. And then what's the equation that's bounding the vase? The vase is being bounded by this curve. So we use the equation of that curve to get our y squared. So we know that y is equal to half x plus 4 over x. Half x plus 4 over x. But according to our equation or formula, we need y squared. So I need to square both sides. So y squared is equal to 1 over 2x plus 4 over x, and this is squared. Okay, so be careful with how you square this. So first square the half x squared. So square the half, you get a quarter. Square the x, you get x squared. And then we're going to do 2 times a half x times 4 over x. By the way, in case you're not following, what we're using is the idea that a plus b squared is equal to a squared plus 2ab plus b squared. And this is our a, this is our b. So that's what's going on. So now we need 2ab, which is 2 times a half x, that's x, times the 4 over x, that just gives us 4. And now square the 4 over x. So square the 4, you get 16. Square the x, you get x squared. There's our y squared. So it means here I should have a quarter of x squared plus 4 plus 16 over x squared. And this is all with respect to x. Okay, so this expression will give us the volume that we're looking for. And so I hope you can see that our integral signs have the same limits. So if that's the case, then it means I can actually just put everything under one integral sign. So what I have is I've got my 81 over 4, but remember we're subtracting our base. So I still have to subtract that equation. So minus a quarter x squared plus 4 plus 16 over x squared. This is all with respect to x. So I've got pi, the integral from 1 to 8 of, yeah, I've got 81 over 4 minus, it's going to subtract that 4. So 81 over 4 minus 4 gives us 65 over 4. And then I've got minus a quarter x squared. And then I've got minus 16 over x squared. But I actually want to move the x squared up to the numerator. And using laws of indices, I know my power becomes negative. So x to the negative 2. And this is with respect to x. Now we can integrate. This should have been 65 over 4, by the way, not 65 over 5. Okay, so if you integrate that, that's 65 over 4x. Then negative a quarter x, add 1 to the power, you get 3 divided by 3. Then I've got negative 16 x to the, add 1 to the power, so negative 2 plus 1, that's negative 1, divide by the negative 1. And our limits are from 1 to 8. So let's simplify this. Got 65 over 4x. And then I've got minus a quarter times x cubed over 3, so that becomes minus 1 over 12x cubed. And then here I've got a positive, that is 16x to the negative 1. I'll just take the x back down, and it becomes x to the power of positive 1. That's from 1 to 8. Now we can substitute in our limits. So start with the upper limit, that's 65 over 4 times 8 minus 1 over 12 times 8 cubed plus 16 over 8 minus, we'll do the lower limit, 65 over 4 times 1 minus 1 over 12 times 1 cubed plus 16 over 1. Okay, so I'm going to punch the substitution for the upper limit into the calculator. So 65 over 4 times 8 minus 1 over 12 times 8 cubed plus 16 over 8. That gives us 268 over 3 minus, now the substitution for the lower limit. So that's 65 over 4 times 1 minus 1 over 12 times 1 cubed plus 16 over 1. And that gives us 193 over 6. Let's subtract these two, and we get 343 over 6 pi, and that is our final answer. Number 11. The equation of a curve is y is equal to 8 over 3x minus 8 minus 6 over x minus 1. Part A. Find the coordinates of the point at which the tangent to the curve at the point 3, 5 intersects the line y equals negative 8 over 6. Oh my, there is a hell of a lot that's going on there. So let's try to sketch out what on earth is going on here. I'm gonna draw my x-axis and my y-axis. I'll start by drawing the line y is equal to negative 8x. So that line looks something like this. And we know it passes through the origin, because when x is 0, you get 0. Okay, so this is y is equal to negative 8x. I'm not even gonna try to get an accurate sketch of this. I'll just draw, for illustration purposes, let's say our function looks something like this. This is y 8 over 3x minus 8 minus here 6 over x minus 1. And let's say the sum point 35, right? And let's say that point 35 is there. If you draw a tangent to the curve at this point, this is your tangent. What is the point of intersection of your tangent and the red line? That's what we want to know. We want to know the coordinates of this point over there. So what I need to do is to first get the equation of my tangent. If I can get my tangent, I'm just solving simultaneously with the red line. Okay. So if I want my gradient of a tangent to the curve, remember that's just dy dx. So I need to differentiate. So I'm going to rewrite y as 8 times, I want to bring my denominator up. So I end up having 3x minus 8 to the negative 1 minus 6. I want to do the same thing here. So times x minus 1 to the negative 1. And so here I've got dy dx is equal to, so to differentiate, bring down this negative 1. So I've got negative 1 multiplied by your 8 times 3x minus 8. Subtract 1 from the power, so negative 1, that's negative 2, multiplied by, now do the inner derivative, so differentiate 3x minus 8. If you differentiate 3x minus 8, you're going to get a 3, so multiply by that 3. Okay, and then I have this negative sign here, so I've got my negative, and then I'm gonna bring down that negative 1, and we're multiplying the 6x minus 1, subtract 1 from your power, so negative 1, that's negative 2. Differentiate your inner function, so differentiate x minus 1, you get 1, so you're just multiplying by 1. So my dy dx here becomes, I've got negative 1 times 8 times 3, so that's negative 24 outside there, and then 3x minus 8 to the negative 2. Then here I've got a negative 1, so that's positive 1, times 6 times 1, so that's just 6 outside the bracket, and then x minus 1 to the negative 2. Okay. And we want to know the gradient of the tangent at x is 3. So we want to know dy dx when x is 3. So our dy dx is going to be, that is negative 24, then 3 times 3 minus 8 to the negative 2 plus 6 times 3 minus 1 to the negative 2. So dy dx is equal to, punch this in the calculator, negative 24 times 3 minus 8 to the power of negative 2 plus 6 times 3 minus 1 to the power of negative 2. So this gives us negative 45 over 2. This is the gradient of the tangent when x is 3. And so now that we have the gradient of our tangent, we also know that this tangent passes through the point 35. So we can use those two pieces of information to get our equation. So we know y is equal to mx plus c. Our gradient m is negative 45 over 2. And then we know our point is the point 35 as they gave us there. And so here our y is 5, x is 3, m is that. So simply substitute. You have 5 is equal to negative 45 over 2 times x, which is 3, plus c. And so 5 is equal to, that's negative 45 times 3 divided by 2. So negative 135 over 2 plus c. So c has to be 5 plus the 135 over 2. That gives us 145 over 2. So this means the equation of our green tangent is going to be y is equal to our m, which is the negative 45 over 2, x plus our c, which is the 145 over 2, right? That is the equation of our green tangent. And now we're saying that we need to solve for the point of intersection between the green tangent and the red line. The red line has equation y is equal to negative 8x. So we can just equate these two. So I've got negative 45 over 2x plus 145 over 2 is equal to negative 8x. I'll move the negative 45 over 2x to the right. So I've got 45 over 2x minus 8x. This is equal to 145 over 2. So 45 over 2 minus 8 is 29 over 2. 29 over 2x. And this is equal to 145 over 2. So to get x, multiply both sides by 2 over 29. Okay. And so we get that x here has to be 145 over 29. Does that simplify? It is 5. So x is 5. They want the coordinate, so we also need y. To get y, I can just use our equation here, y equals negative 8x. So y has to be negative 8x, x being 5. So y has to be negative 40. And so therefore, our coordinates of that point of intersection are 5 and negative 40. That is our solution for 6 marks. B part 1. Find the x-coordinates of each of the stationary points of the curve. So stationary point, first thing you should think of is dy dx is 0. And we already evaluated dy dx in part A. Our dy dx is this expression over here. So let's copy that down. That's your dy dx. And we're saying that this has to be equal to 0. And here I'm just going to take this bracket here down, as well as the second bracket down to the denominator, so that I'm working with positive powers throughout. So I've got negative 24 divided by 3x minus 8, and this is squared, plus 6 divided by x minus 1, and this is squared, is equal to 0. And so what we can do, guess the easiest is I'll just move this first term to the right hand side to make it positive, and then we'll cross multiply. So 6 over x minus 1 squared is equal to positive 24 over 3x minus 8 squared, and we can cross multiply. So I've got 6 times 3x minus 8 squared is equal to 24 times x minus 1 squared, and we can expand. So first square the 3 here, you get a 9. Square the x, you get x squared. Then 2 times 3x, that's 6x, times negative 8, negative 48x. Then square the negative 8, you get a positive 64. We'll do the same on the right hand side. So square the x squared. 2 times x times negative 1, negative 2x. Square the negative 1, positive 1. And now multiply. So 6 times 9x squared, that's 54x squared. 6 times negative 48x, that is negative 288x. And then 64 times 6, that's 384. This is equal to 24 times x squared, so 24x squared. 24 times negative 2x, negative 48x. 24 times 1 plus 24. Okay. Now let's put everything on one side. So I've got 54x squared minus the 24x squared minus 288x plus the 48x plus 384 minus the 24, and this is all equal to 0. So 54x squared minus 24x squared is 30x squared, and then negative 288x plus 48, that gives us negative 240x. And then 384 minus 24 is going to be 360. And this is all equal to 0. Looks like everything here is going to be divisible by 30, so I'll divide through by 30. So 30 divided by 30 is 30, then 240 divided by 30 is 8, and then 360, this should be 8x, and then 360 divided by 30 is 12, and this is equal to 0. Now we've got a nice 3-term quadratic. Can we factorize this? Yes, we can. So we want factors of 12 that add up to -8. So we can do -6 and -2. So we get that either x is 2 or x is 6. Okay, and those are the x coordinates of each of our stationary points. So that's going to be our final answer. Now part 2 says find the second derivative and hence determine the nature of each of the stationary points. Okay. So we know that our dy dx was this expression here, so I'll just copy that. This is dy dx. And we need to find the second derivative. So we need to differentiate this. So d squared y dx squared is equal to, bring down the -2, so -2 times -24 bracket 3x minus 8, subtract 1 from the power, so -2, -1, you get -3, multiplied by, differentiate the inner function, so differentiate the 3x minus 8, you get a 3, so multiply by 3. Now bring down the -2, and it's multiplying your 6 times the bracket, then -2, -1, so -3, differentiate the inner function. If you differentiate x minus 1, you're going to get 1. And so that means our second derivative is equal to, so -2 times -24, that's 48. 48 by 3, that's 144. So I've got 144 times 3x minus 8 to the -3. And then here I've got -2 times 6 times 1, so that's -12 x minus 1 to the -3. All right, that is our second derivative. And they say to determine the nature of each stationary point. Okay, so we can start, we know the x coordinates of each stationary point. So we'll start with x is 2. At x is equal to 2, my second derivative is going to be equal to 144 times 3 times 2 minus 8 to the -3 minus 12 times 2 minus 1 to the -3. So let's punch this into the calculator. 144 times 3 times 2 minus 8 to the -3 minus 12 times 2 minus 1 to the -3. That gives us -30. And we'll also do at x is 6. So at x is 6, that's 144 times 3 times 6 minus 8 to the -3 minus 12 times 6 minus 1 to the -3. So this is 144 times 3 times 6 minus 8 to the -3 minus 12 times 6 minus 1 to the -3. And that is 6 over 125. And so now let's make our conclusion. At x is 2, our second derivative is equal to -30, which is less than 0. Hence, this is a maximum point. And at x is 6, our second derivative is 6 over 125, which is positive. Hence, this is a minimum point. Okay. And that would be our final answer.